Written down my given. I have the different choices we have to choose from to prove a triangle is congruent, rather than having to show all 6 sets of parts. We can just show 3 sets of corresponding congruent sides, side, side, side. Maybe 2 sides and there include an angle, that's side, angle, side. 2 angles included side, angle, or 2 angles and they're non-included side. Have those listed up at the top. See if they gave me anything already. It looks like I already have a couple of things that would be the same, JS and KS, and those do correspond if this is a reflection. So if you wanted to change those to congruent, we could do that right now. You could wait too, because I have a feeling we might end up changing some other stuff. But if it helps you to keep track of where we are and what we have, maybe we'll go ahead and do that. Definition of congruent segments. You have a set of congruent segments. I'll go ahead and label that. They correspond. Maybe I'll highlight one of the triangles so we can see from one of the triangles which parts we have. So I have that one set of sides. That's all they give me. Maybe looking for some other stuff. You see something already. Why don't we try to see if we can get anything from the given? What do you know if angle 1 and 2 are right angles? Well, what does it mean to be a right angle? So let's just use that. By definition of what a right angle is, what would you be able to say? Well, by definition, angle 1 and angle, okay, and be more specific, and angle 2 are going to equal 90 degrees. Well, their measures equal 90. So measure of angle 1 equals 90. The measure of angle 2 equals 90 degrees. That's just what a right angle is. Now that doesn't say they're equal quite yet, but you could do a little replacement rule and say, well, if angle 1 equals 90, replace 90 with what else equals 90? Measure of angle 2. Replacement rule, which is really close, just a matter of changing it to congruence. The reason I'm changing these statements to congruence is because all 4 reasons I have up at the top, I'll circle them again, all 4 of those say if the corresponding parts are congruent, then the triangles are congruent. So I need these corresponding parts that I have that are equal to be stated congruent for me to be able to use them in my proof. So here I had a set of sides. This is now a set of angles. I'll label 1 and 2 in my picture. That's a set of angles. Usually don't label both triangles, so we can if we want, but I'll just do a side and an angle. Need a third one. All of our choices use at least 3 sets of corresponding congruent parts, so we're not done yet. We're still looking. What else do I have that's the same? Well, if you've already watched the first 2, maybe you'd realize we're going to do the same thing we did there. You have this reflection where they share a side. This set of sides in the middle should be congruent. Alright, well, let's write that down. RS congruent to itself. This is RPC. If you wanted to say equals, it'd be RPE. It'd be a property of equality, but as it is, it's a property of congruency. Reflexive property congruency. Something is equal to itself, or in this case, congruent to itself. That is our third one that will get us there as long as it kind of lines up the way it needs to. So let's look. 2 sides and angle. That would more than likely be side, angle, side if the A is in between the 2 S's, which it is. Side, your included angle in between there, side. So we can justify the triangles are congruent with that. Side, angle, side. Therefore, triangle RJS is congruent to triangle RKS.